This is going to be the crash course in FreakHead. And so I think what we'll be modeling mostly is going to be commercial parts, fasteners, hardware, etc. Sometimes you can download that stuff, and FreakHead does have a library of hardware, but we're going to make it all from scratch so that we're very consistent in how we do it, and we're not dealing with the limitations of other creations. And so we'll start with the most basic component. I think there's going to be some washers in this thing, like a FlatWasher. And I know that there's like a washer that looks like a gasket that looks like a washer too. So essentially, what is that? That's like, it's like a cut off piece of a cylinder that has some thickness. And if you look at that, there's a couple ways to model it. If we assume that let's put a coordinate system on this that's, X, Y, and Z comes up, right? Do we know the right-hand rule? If you ever get confused about which way the z-axis goes, so you sketch your x-axis and the y-axis, what you do is you put your pinky along the x, roll your fingers towards the y-axis, and the direction your thumb points is the direction of the y-axis. So this y-axis for this x and y would be coming, positive z would come up through the paper. And by now you probably have seen it in CAD systems. They normally color the x as red, the y is green, and the z is blue. That's pretty consistent, I've noticed in a lot of these CAD systems. I don't know if that's going to be clear enough to see. But anyways, okay, so let's get back to this washer model. There's two ways to, for any solid model, there's always there's a handful of ways to create it. Sometimes it's personal preference, and sometimes there's obviously a better way to do it. And a washer is one of those things. Well, there's probably two main ways to do it. Excuse me. One is to, let's say we have our x-axis and our y-axis. We can sketch a circle with its origin on the 0, 0, xy 0 point, and we can sketch another circle, and then we can extrude it to give us thickness in the z, either the positive z or the negative z. That's one way to do it. Another way to do it is this is our x-axis and the y-axis, is to sketch a rectangle out here. Oh, and by the way, back over here, we would give this a dimension, and so the outside dimension would be abbreviated OD, and then the inside dimension is abbreviated ID, and then there'd be a thickness, maybe it's T or something like that. So those three parameters define the geometric size of a washer. So if we were to do it a different way, we can sketch the cross section of the washer, and then what we'll do is revolve it about the y-axis to create our shape. So in this case, we would dimension from here, from the origin to the outside, and that would actually be the OD divided by 2, and then the inside would be the ID divided by 2, and then this would be the thickness. There's three choices, right? You could have it extruded above, you can have it above the x-axis, you could have it below the x-axis, or you could have it on the midplane of the x-axis, depending on what you're going to do. So, but anyways, that would be the thickness. And then the feature would be, this cross-section would be revolved. Whereas over here, we'd be extruding or padding, what we calls a pad, the annular circle to make the washer. All right, so that's kind of like the theory. Now let's do it in FreakHead. So let's see, we're going to turn this back on. Okay, so I have a shortcut to FreakHead, and I've upgraded to 1.1.1. So we're going to be in sync there. And I should have probably opened this before. Here it comes. Oops, this is taking forever. I'm going to pause. Okay, FreakCAD came up, so I'm going to open a new file. So file, new document. And you notice over in the lower right corner, we see there's, just like I said, the X is red, the Y is green, and the Z is blue. Likewise, up in the upper right corner, you have this view icon, which has the same colored triad, and you can click on those faces to get the view that corresponds to its either name or what have you. Another nice thing here is you can do click on the actual this little symbol of the cube, and you can say, this is a good one to say fit all. Whenever you lose track of where your part is, you might find that handy. What else is over here? Orthographic or perspective, and not the important. Fit all, fit selection. Yeah, so maybe that fit all is kind of the best command there. And also they give you a shortcut here, VF. Now, I'm not really sure right now how these shortcuts work, because sometimes they work and sometimes when you switch to a different task, they get remapped and what have you. So I'm not really 100% sure how they all work. Okay. And by default, it came into the part design module, and the bulk of your work will be initially be in part design. So don't get confused, because there's a part design and then there's a part. The best way, it's like from your experiences, I think like part is more like Tinkercad, where you work with primitives, cubes and so forth, and you join them and what have you. Whereas part design, I think, is more like Fusion. I mean, part design is more driven, 90% of your stuff is driven from a 2D sketch, which you then either revolve. Is that what they call it? Let me see. Either you pad it, which is like an extrusion, or you revolve it. And then these other, the loft and the sweep and so forth, they're more advanced types of 3D constructions. Okay, let's see. Let's not get all tangled up here. So there's some persistent commands, that toolbars that stay, just like any software, like there's save and rebuild the model, and like this is the measure icon, blah blah blah. This thing's always safe. And then these are more general, like high level commands. This is to make a part. This is to create like reference geometry. Create an organizing folder within your tree structure. This is to create variables. This is to create a sketch. Sketch, you're going to become expert, hopefully, at doing sketches. They're the fundamental thing before we create a solid model. And then the way these icons down here, which are the core part design ones, are organized, is the ones that are in yellow are like additive features. Your extrude, your pad, your revolve, your loft, blah, blah, blah. The ones that are blue and red are subtractive features. So there's an extrude a cut, or the hole is it has a table of all the types of holes you can drill and tap and so forth. So you can use that to quickly get the right size, like tap drill, if you're going to put a tapped hole in a part. And there's a revolved cut and a subtractive loft, yada yada. And then you get over to these are kind of like your tweaking of the solid model. There's the fillet, the chamfer. Draft creates walls that are tapered. So if you're making a molded part that'll release from the molded or cast part, it's something you don't really recognize when you do just 3D printing, because 3D printing doesn't have a mold. So not all 3D prints will translate right to a molded part, because you need to have draft. Otherwise the part, if you have parallel walls, you can't really extract the part from the mold. Then these last four icons are like patterning, like mirroring and a linear pattern, a polar pattern, and a combination of patterns. Let's see. I think that maybe that. And so over here you have a tabbed interface. There's a model tree, and then there's a task panel, which brings up commands that are specific to whatever command you're in. So we're going to make a washer. So this unnamed is the name of my file right now. So let's first save our file and give it a name. And I have actually a folder for FreeCAD stuff here. So get organized right from the get-go. Actually, where did I put this? This is going to be under work. Oh boy. Okay. Call this training number 1. Okay, so there's the name of our folder. It's also up here in the header of the window. So I'm going to first create a container. So a new part is essentially just a container that contains an origin. So if we turn that origin on, we see there is our triad, and it also includes, it has 3 axes, 3 planes, and the origin point. I can do it. So I like to use, a couple other things. There's options for which keyboard style you like as far as how you 3D rotate and pan and all that. I use Revit because it's similar to what Autodesk Inventor uses, so I've just been using that one, but that's personal preference. I believe you can also, down here you can switch your units. It doesn't, so you can work with other units are convenient to you, like 25.4 millimeters. If you switch to inches, it'll be 1 inch. So that's, you don't have to rescale. It has engineering units built into it. You can also change that under Edit Preferences over here for the document, I believe. Did I get it? Here we go. Let's see, General. Yeah, right here, Default. Decimal inches, blah, blah, blah. You may want to, on the Sketcher tab, I turn off this Escape key, can leave the Sketch Edit mode because I find that to be annoying. I always hit Escape to back out of things and then it exits the sketch. I'm jumping around, sorry about that. But you'll get once you start working, you'll find out if there's a lot of different preferences you can change to how you like to work. Okay, so you don't necessarily have to have this origin turned on, but it's just a part, every part has an origin and it's fundamental. All right, so like I said, we'll make this washer 2 ways. First, we'll make it with the extruded concentric circles. So we need to sketch those circles. So I'm going to say create a sketch, new sketch, creates a new sketch, and then it wants you to select a plane. So if you can either pre-select the plane or you can select it after you enter the command. So in this case, I didn't pre-select the plane, so now I have to select it. You see it prompts me over here. Oh, I should back up. One thing you have to do is you can have multiple parts in one file, and you have to tell FreeCAD what is the active part you want to work on. So you have to right-click it and make the part that you want to work on the active object. Now, since there was there weren't any parts in this file, and then we created a part, it defaulted to make it the active object. But you'll find that this will get you hung up if you don't have the active object. And then you have to add a body to the part. So the body command is this blue square. So we have to create the part, add the body. Maybe we should take some notes on this, huh? Okay, so create a new part. Oh, maybe we should do this in a better place. Hold on, I'm gonna pause. Okay, I can't remember where I left off, but anyways, we create the part, and then we made the part active, I believe. Okay, active object has to be toggled on, and the part has to be bold. Okay, then we need to add a body. The body is this blue symbol up here, new body. So we create the new body, and then by default it should also be active also. Okay, so now we have a container called the part, which has an origin, and then a body, which also has an origin. And these two origins are in the same spot, I believe. You can see that if I turn them on, they overlap. Normally they're just turned off, but anyways. Okay, so now with the body active, we can now create a sketch, and we have to decide which sketch plane we want. If we don't pick a plane and we hit the sketch button, it'll ask us to pick a plane. So in this case, we'll pick the XY and say OK. And then what it'll do, I think in your preferences you can set, it makes you normal to that plane. So we're looking down the Z-axis at the XY plane, and that's called top over here on the right. So now we can begin sketching our 2D geometry. Now, it's important to keep track and to think about how the part's used and so forth, that you don't, like, since we're designing this washer, and the washer has an axis through the middle that, you know, the bolt would line up and the hole that it would line up with, we want to preserve that. We don't, for instance, want to sketch a circle. Notice the toolbar changed now to like the sketch style items. So we have points, polylines, lines, arcs, circles, rectangles, geometric shapes, blah, blah, blah. And then we have constraints. So if we can take a circle, and it's indicating with the red dots. You have to select a center point and an edge on the circle. So randomly, I'm going to pick a center point and an edge on the circle and release. So when you first draw something and it ends up in white, that means that it's unconstrained, which means there's not enough, it's not defined to really fix it. For instance, you'll notice I'm still stuck in the circle command, so if I hit another, I'll get another circle. But if I could push escape, get rid of that, and I can close, well, if I close, I exit the sketch. You can see now in my tree I have a sketch. If I want to edit that sketch, I double click it, and it comes back. If I click and hold on the center, you can see I can move this around the center point wherever I want. And I think if I click the edge, I can resize the diameter of the circle. Well, obviously that's not a very good design. We need something that's more rigid. So like I said, we want to have the center point along the z-axis. So we want to constrain the center of the circle to the origin. So there's a couple ways to do that. First of all, we have to know that this symbol here, which shows like a point being put onto a line, is the coincident constraint, which means make things stay on the similar line. So we can click this circle and do control click on the origin, and then we can click coincident, and it'll force those 2 points to stay locked together. And now I can't move the center point if I try to drag it, but I still can change the diameter of the circle. So this needs some kind of constraint. So that would be, I can take the dimension tool, and this dimension tool is like kind of context sensitive. If it sees we're on an arc, it'll give us either radius or diameter dimension. If we're going between points, it'll give us a straight line. If we're between lines, it'll give us an angle. So let's just say this is going to be a 1-inch diameter circle, and there we have a 1-inch diameter. And now it's turned green, and green means that everything's constrained. It's fully constrained, like there's nothing ambiguous about this shape. You notice over here in the task we have the tasks now are specific to making a wireframe 2D sketch, and it shows our constraints over here. As a matter of fact, we can, you can select them instead of selecting them on the screen, and it's showing us that we have one arc. I can turn it on and off. You don't really use this that much. Okay, so we can say close, and there we have our 2D circle. I don't know what this point's doing out here. Let's go back and look at that. I don't know. Well, I guess that's just some anomaly. I've never noticed that before. But anyways. Okay, so we can go ahead now and we can extrude this if we want. Or they call it making a pad, so we pick this. And then it makes an assumption about the thickness and the direction. But you can see here, at first I can change the length. What they're calling the length is really our thickness. I can make it 0.1. Well, of course, it ran off and did it. I can double click that. If I could expand the pad, it shows there's our sketch. So the sketch is a child to the pad. I can still go back in and modify my pad if I want. I can change this to 0.75. And then say close. And now I have a new diameter there. If I want to change the pad, the things regarding the extrusion, like for instance, I could flip the direction by saying reversed. Now it goes the other way. Or I can say that it's symmetric about the midplane. So it'll be 0.05 positive y, 0.05 negative y. And there's some other things here you can play with. Okay, so we can say okay. Now we could, now if we need to put the hole in the washer, we could sketch on this one of the faces, the front of the back, and first what we can do is we select that face, then we can go to the new sketch and it'll attach the sketch to that surface. See, now the sketch is on that surface. Remember, currently it's extruded half one direction, half the other. So if I turn on the origin, you can see that very faintly that the YZ plane is in the middle of this part. But I'm sketching on, well, I exited the sketch, I'm sketching on one surface. So now I can add another circle, and instead of having to put the centers to place, we can actually snap onto that origin as we pick, instead of having to do it as a separate operation. Okay, there's a circle. You can see I can drag the diameter, but I can't drag the center point. Okay, so let's put a dimension on here. Excuse me, 0.5. Now we can close this, and instead of extruding this as a pad, we can do it as a cutout. So here's what they call that, a pocket. And as far as the depth, we can give it a numerical depth, or we can just say go through all and say okay. So now we have our washer, which has two features, right? It has the initial pad and then the cutout pad. That's one way to approach this. Now I can delete this feature. So the one delete will deletes the pad, or in that case it was the cutout. The next, I can now delete that sketch. So another way, we could have put both of our sketch circles in one sketch. I could go back here, make this diameter 0.5, and say close. And now I have the same thing with only one feature. So from a maintenance standpoint, if we wanted to make a series of washers, it's a little bit easier to open one sketch and change the ID and the OD in as one task versus having to individually open the first pad and then the extrude to change the ID. So you still get the same result, but sometimes one way is a little more efficient than another. Okay. What else to talk about? So we can create this part a whole nother way. What I'll do now is I'm going to find my mouse cursor. The eyeball over here is like turns things on off. That's an eyeball. So you can see now the part's not displayed. And by the way, I'm going to use F2 and rename this washer extruded. Okay, I'm going to turn it off. Now I'm going to create a washer another way. So I'm going to add another part. And I'm going to rename it right. I'm going to say washer revolved. And it's the active part. So here I started writing the procedure. Okay, so we're in part design. We added a new part, then we have to make that active, then we have to add a body, make that active, then we can make a sketch. So this is active, so now I add a body. Okay, now the body, it automatically names them. You don't have to rename the body. That's not necessarily. So then that is active. So now I'm going to make a sketch on the X. Well, in this case, let's just go on the YZ plane to make things different. Okay, now instead of sketching a circle, I'm going to sketch the cross section of the washer. So the washer cross section really is a rectangle that I can then take that section and revolve it around the y-axis to get a washer. So here I can do my dimensioning. So for instance, this can be my thickness, which we made 0.1 in the other case. And then I'm using D as a shortcut for dimension. I can go from this axis to the outer, and this is going to be my OD. But if the OD is 0.75, that's really only, that's the radius. So I can put in 0.75 divided by 2, and it'll do the math for me. That'll be 3/8. There we go, and we say OK. And now you see this line is now turned green because it's fully constrained. But the other side is not fully constrained. Really, we need it over on this side to make the ID. So I'll put the ID in here as being, it's like, what do we say, 0.5 divided by 2. 2. Okay. Okay, now we have fully constrained. Everything's green. We can say close the section. So now we have that cross section out in space, 2D. And now I can do a revolve. Oh, I hit the wrong command. I did the subtractive revolve. So I'm going to do the, over here, additive revolve. Okay, and it looks like it's giving us a preview. Now, it doesn't necessarily always work out this way. It just so happens that because it wants a axis to revolve about, because it could have, if we'd sketched on a different plane, it might have picked a different axis to revolve about. So this is a legitimate revolution going around the x-axis, but it's not really what we want. You notice we have all these choices here. So we want either the vertical or the y-axis. It's the same thing. Okay. So more choices, but we're good. We say OK. Oh, what's that? Base Y. What's wrong with that? There we go. I don't know. Okay, so now we have the washer the other way. Okay, so now I'm showing both washers. Now the reason they kind of overlap kind of funny, oops, is because the one we extruded from the midplane and the other one we didn't. Now it gets confusing because they're the same color. So to change the color, you can click on the body and right click, and you could say just random color and it'll pick a random color. Let's see, now we're still seeing interference. So that's the revolved one, and then that was the extruded one. So it's a personal thing, but I like the revolved better because I can go to this cross section of the revolution and I can change all 3 parameters in one swoop without having to go to other places. So it's kind of convenient, and I can straighten these dimensions out a little bit or whatever. Okay, so it's kind of a odd proportion washer, but that's basically what a washer would look like. Now you can do, sometimes you have to use your judgment. How much detail does the part need, right? Because you could come in here if you want and select these corners, these edges, all 4 of them, and you could say put a chamfer on there with the chamfer tool. Make it say 0.01 inches. So now you have the kind of the edges are broken. It looks real beautiful, but may not be necessary in all cases. And so you notice now our tree for the revolve washer has a chamfer as the last step and a revolution. So if you want to go back to what the revolution's all about, you can unhide it and it kind of rolls you back to that step. You can see how in the tree, the thing that's in bold in the normal coloration is the active, and you can go back to the chamfer by clicking on it. Alright, so that's the washer. I'm going to stop right there. Make sure you save your work too, file save, or hit the save icon.